Welcome to the AI innovation space. We are your experts, and I'm Iyanu.
And I'm Todd.
We're here to offer our unique insights and hold conversations with top leading innovators in the world of AI and machine learning.
We dissect and discuss the often complex realm of AI in an accessible way and go deep in discussing the innovative technologies that impact our lives every day.
This podcast is sponsored by Ellumen, an IT contractor offering a creative and human-centric approach to medical imaging, cybersecurity solutions, training and support, and more. Ellumen's values of ingenuity and connection make us a leader in adopting innovative technologies for federal healthcare and beyond.
Visit Ellumen's website at www.ellumen.com for an overview of the services offered and to read our blog series on leveraging AI for your business. Thank you so much for listening, and let's begin.
Hi, welcome to another edition of the AI Innovation Space. We're really happy to have you on. I'm here, and my co-host Todd is here with me as well. Hi, Todd. How you doing?
Doing good. Looking forward to an exciting episode today with Glenn.
Same. So we have Glenn. Glenn is here with us, and I would like to have Glenn do a little bit of an introduction of himself, and then we'll get right into the mix of things. Awesome. So we're going to get right to it. So, Glenn, do you mind doing a little bit of introduction about yourself, some of your work, your previous work, and yeah, we'll get into it today.
Yeah, so thank you for inviting me, first of all. And my name again is Glenn Fung. And I kind of a little bit about my background. I got an undergrad in bachelor's in pure math and in Venezuela, where I'm from. And then I got a master's in the University Simon Bolivar, that is also kind of Caracas, Venezuela, over there, and in applied math, and kind of concentrated in optimization and operations research. And then I came to the United States. I was a professor there for 2 years in that university, and then I got a scholarship because this kind of the way the university worked at that time is you can start more like as assistant professor, like a kind of a more junior professor with your master's, and then but you committed to do a PhD, and so I got a scholarship to come to the University of Wisconsin in Madison, where I currently live right now. I still in Madison. I moved back and forth different places, as you learned through the interview. I mean, we talk a little bit about places where I work and my experience. But yeah, so I started my PhD in computer sciences here. I got a master's on the way too on statistics, kind of a minor in statistics, and then my idea was to do more like an operations research in the computer science department because that's what I was doing when I came. And I wanted to work with this professor. He was a very well-known professor in the area of operations research and optimization. His name was Olby Mangasarian. And I took a class with him about linear programming, and I kind of played the try hard. I really try hard because I wanted him to notice there was big classes like and then I do extra work and stuff, and it worked. It worked out. So he at the end of the class he told me they want to work with him, and he was doing this thing called machine learning, and I had no idea what it was, but it fell in my lap, so I feel lucky about that in a way. And then, yeah, so that was 1999. So I started doing machine learning back then, and I haven't stopped doing it. I'm so lucky. I feel like I'm so lucky to be in the field. And that's what it is. It's not something that I thought, when I was younger, I want to do robotics or machine learning. It didn't happen like that. It just fell on my lap just because of the link between optimization and machine learning is very strong. And that's why I got into it. So I don't know, you want me to kind of go a little bit about kind of places where I work
Well, Glenn, I'm just kind of curious. So you mentioned how you got into machine learning in the late '90s with your professor. What kind of work was he doing at the time, and what were you helping him with? I guess what kind of
Yeah,
problems were you guys looking at?
that was the time of the support vector machines. Like kind of the rise of the support vector machines, and with Babnik, and he claims that he invented them in '65. Babnik say that he did it in the '70s. Truth to be told is that they both came out with a similar idea, and Olby came out with the optimization point of view of the same idea, like a kind of separating hyperplanes for classification, but in the 65, a long time before, but didn't make it out there until Babnik, that he used to work for AT&T Labs, and it was like a big name back then. He did more like the Bayesian statistics approach, and that's what when they picked up. But yeah, so it was mostly like optimization. People were trying to figure out how to solve this massive at the time. Of course, it doesn't compare what we have today. But yeah, so a lot of optimization and solving QPs in smart ways, and how we can extend it to multi-class. It was kind of the beginning. And it's funny because you think about it, at that time, I remember being a snob against neural networks at that time, because the hot thing was support vector machines, and everybody was doing neural networks saying, no, that's not
the case anymore. Yup.
that's from the past. It's funny. Although on the way, because it was so hard, and we published a bunch of papers on that, and all was kind of really well known. I got the chance to go to conferences when they were smaller. It's funny, like NeurIPS, former NIPS, was like 300 people, something like that. I got to go to those conferences and meet like Joshua. I got to meet people, Pedro Domingo, so I knew people from back then, and being these small groups, like hearing about the work they were doing, and stuff like that. So it wasn't a blessing. It was a very academic thing going on, in the late 90s. It wasn't like this boom that we had today after the renaissance of deep learning, but it was very interesting to be around on those times.
I see. Very interesting. Yeah, I've had some experience with operations research myself, so it's kind of interesting how that kind of ties into getting involved with machine learning. So that's interesting to hear. So yeah, go ahead and tell us about some of your earlier roles. We noticed you were working with Siemens for a number of years. If you want to share with us some of your earlier type of roles after you were at Wisconsin.
I started in 1998 my PhD, and at the end of 2002, I'm almost ready. So I've already published several papers, and we were like, okay, you're ready to graduate. My advisor, of course, wanted to get a few more papers out before I left, and I started looking for jobs. And it's funny, I don't say this that much, but I'm gonna say it today. Like my two contenders were like Siemens. At that time, I had some visa issues, with immigration stuff, because I came with a special visa, J1, and I married a person from Madison. My wife is from Madison, Wisconsin, but that still didn't matter. It was something special visa, and I needed to figure that out. But Siemens kind of was doing this really interesting thing, putting together, very visionary, I think, by the time, putting together a team of computer vision, scientists, and early machine learning scientists. And it's funny because that class of people who were there, they're all in the industry right now. I mean, they're all people that still in leadership positions in the machine learning field, like in different places, Pinterest, LinkedIn, all around Amazon, different people in different places. So they offer that, and it was very interesting. So I ended up going to that. But the other company, it was this relatively small company in 1990. That was like 2002 coming up, doing search on the internet called Google. That was the other one. But I decided to go to Siemens because it was a very big company, and I thought it would be better for my situation at that moment. But that's a funny story. Yeah, so after that, I kind of worked there for 10 years. So I made my way. They had a really good program about being able to progress in your career and being an individual contributor. Still, you didn't have to be a manager. So I ended up being something that they call key principal expert in machine learning, doing medical applications. At the beginning, we were focused on these computer-aided diagnosis systems that it was all on top of CT scans. CT scans is kind of this multiple X-ray taking slices, and then you can form a 3D rendering or a 3D picture of parts of your body. And then what we were was in long cat. The lungs has a lot of little structures, but sometimes there is this kind of little balls or spherical structures that are interesting because they might be cancerous. So we created the first FDA-approved system for long cat over there. And my role was to create the support vector machines that were inside, like classifying, that based on features. At that time, we didn't have CNNs or anything like that. So it was more like, well, based on all these engineering features that computer vision people got, a lot of characteristics about how rounded it was, different contrast stuff, and then feeding these features to a support vector machine, doing feature selection and creating that. So I was part of that team, and then it was successful. So we got FDA approved, which was a very long process at that time because it was pretty new, this kind of technology. Then we did one for pulmonary embolism and one for colon cancer as well to detect polyps. So I worked on that for a while, and then at the second part of my stay there, I was more like a mentoring, doing innovation for medical applications, a lot in the field of personalized medicine, hospital readmissions, like kind of the beginning of starting to create these models, using NLP for checking practices based on structured data and stuff like that. So I did a lot of that when I was there. So after that, I was there for 10 years. I was approached by Amazon and I moved to Seattle to work as a principal research scientist on the kind of the backbone back then. I think AWS, I mean, I still the backbone, but AWS has a big part now that in the retail doing, applications of machine learning for information extraction, both for pricing and for checking some of the stuff that you want to check automatically in marketplace. For example, there are these websites so Amazon doesn't want to sell guns, for example, right? And one thing was how we can kind of scan automatically the web pages and kind of highlight or kind of tag the ones that it might be a real gun, but it's not as easy as it sounds, right? Because there are toy guns, there are, glue guns. There are all kind of different guns that you want to sell, but you don't want to sell like the weapons kind of guns. So I applied. There was very interesting because I got to apply. I worked there for a year, almost 2 years. It was very interesting because I got to apply active learning in an industrial setting back then. I mean, I'm talking about that was like maybe 10 years from now. But it was really interesting for both price extraction and this kind of website classification and stuff like that. And then for family reasons, I needed to move back to Madison. And because American Family Insurance has a big, footprint in Madison, Wisconsin, I kind of got in touch with them. And at that moment, I said, well, I want to do something different. And I kind of convinced them to make me a manager. I'd never been a manager before, and create a machine learning team for insurance applications. And yeah, so I worked there for almost 9 years. It's right here in Madison where I live. Again, my wife is from Madison. We have a big family here. And it was until like 3 or 4 months where I say, well, the world is changing. I always get all these different opportunities to do some things that are a little bit different. And I kind of was attracted by the idea of working. There are different things that were really attractive about going and work for Liberty. And I'm working there now, leading head of data science in an innovation lab that is called Solaria over there.
Wow. Wow, that's so awesome. Man, I would love to ask a few questions around, some of the things you did while you were at Siemens, right? You had mentioned about you guys using support vector. I was just curious, what were the levels of accuracy that you were getting while you were working there on some of your work?
Yeah, I mean, but with the computer vision stuff, again, it was a process of trial and error. Yeah, because you work really close with these computer vision engineers.
Yep.
Need to go and brainstorm about new features, and like they created a bunch of features, right, based on computer vision. And then we kind of run these feature selection stuff. And the good thing about that, I will say, is like there's a lot of commoditized code nowadays. Back then wasn't the case, so we
Yep.
actually create
Yep.
code for everything, and also like customized solutions. For example, we noticed that these are, and we published a lot of papers when I was there. So because of this, and they were pretty open to it, and we filed patents, a large number of patents. But a lot of the classification was exciting because things weren't solved as much. We weren't as mature in machine
Yep.
learning as we are today. So, for
Yep.
example, I remember even when everything at the end was based on support vector machines, they were all like, okay, we know support vector machine is really good when we assume that the training data set is IID. The assumption, is like you have a data set, and every data point that you want to use for training and for testing for the purpose is IID. So it's independent from each other. They're taken from an independent distribution. And we noticed that that assumption is often violated, but it doesn't matter that much. But here, when you take a CT scan, it matters if you find, I mean, like we noticed that some of these lesions that we're looking for, they occur in clusters. And if you have one, you're very likely to have another one.
Mm-hmm.
So we started like creating versions of support vector machine that take correlation between the things that are candidates to be a node. They call it a nodule or not, for example, or a bump. So that we had to kind of engineer the algorithms and try different things. And so there was a lot of that when I was there, which was very interesting because it kept us in our tippy toes. Like either publishing or creating new algorithms and stuff like that, right?
Yep.
So that was part of that kind of marked my career from there, because even when I have been in the industry for all this year, I'm always kept a tight relationship with academia, and especially just because of geographic locations with the University of Wisconsin. So I still to the day, I mean, we got a paper accepted in ICML, what I did with a friend of mine that is actually a computer vision expert at the University of Wisconsin, Professor Vika Singh. I work with students. We publish papers every year with different part of my friends, like academic friends that I do. It's not part of my job necessarily. Sometimes they're part of my job, but sometimes are not. Like more of the applied papers are part of my job. More in American Family, because I kind of brought that culture of let us publish. The scientists are going to be happy. And I actually there it was pretty cool because I convinced the CFO to create a relationship with the University of Wisconsin, and we created this thing called the Data Science Institute, and they kind of invested 20 millions into that, and we were kind of funding research through the insurance applications of $1 million a year, which is not too much, but it was like 7 or 8 projects a year. Well, the point is that I always been close, even when I've been in industry, I always been close to academia my whole career. And independent where I am, I always try to publish and stuff like
Publish.
that.
Yep.
In Amazon was a little bit harder at that point because we were part of the retail and they were very secretive about what we were doing, so I didn't publish over there. But because I was leading the whole team, and my team started with 4 scientists, ended up with 30 before I left
Oh,
American
wow.
Family. But there we did a lot of research, and UW, University of Wisconsin, kind of collaborations and stuff like that.
Wow. Wow.
Um,
So is it possible for you to share about what Solaris is about? What
yeah,
you
sure.
do and
Yeah,
all.
yeah, yeah. So something that it was very attractive to me about Solaria is like I noticed. So in my career, I always say like I've been pretty good about doing what I call invention, and what I call invention is like coming from this technical side that I am, because I'm always, even when I've been a leader and in data science, I'm always feel like at heart I'm a scientist. That's what I am, right?
Mm-hmm.
And then I feel like the teams that I put together are really good about understanding upcoming and new techniques, or even creating new ones when we publish papers of data science and machine learning, and creating things that are really cool, and we can experimentally apply to the field where we're working. In the case of American Family was insurance, right? But that for me are inventions. So we get all these kind of POCs and we get all these cool ideas, and then we can show, oh, look at this. If we use a large language model this way, there's all this cool stuff that might happen, and we might apply in A, B, and C or different things in insurance. But I think the challenge is the adoption of those inventions. That's what I call innovation, right? It's a difference for me between invention and innovation. So innovation for me, again, invention is taking kind of the resources and the brain power and creating new ideas. And for me, innovation is a process of taking those ideas and connecting to final value. So we have really good successes through I mean, in my career, in Amazon was much easier in the insurance domain because, it's insurance is not as mature using, I mean, it's coming up, there is a lot of insure tech and it's coming up, but in these 8 years have been a long journey. I noticed that was harder, but I always had a bigger probability of winning when I was partnered with product teams. So the philosophy of product and product design, that was something that always helped me, and I was a big fan of it. I felt like product was kind of when you have a band or something, and you're in your garage, playing music, and you have a tape, and somebody comes, and say, "Oh, that song is really good. I'm gonna take it to the record labels and see if somebody wants it." That's kind of what I see product, right? Take these ideas from the garage and take it out there. So I always was a big fan, and some of my big successes have been because of product. So, and Solaria lives in our organization. So Liberty is very mature in kind of the product philosophy, and we live. Solaria is an innovation lab that the goal is to, again, to take new technologies and new ideas and try to see how they fit not only into the main US, because Liberty is a company who has operations in 12 countries, and some of the markets in other countries are smaller, so it's easier to innovate in the smaller markets. So Solaria takes ideas and kind of pilot their ideas through product in different markets, and then if the ideas kind of are promising, we bring it back and try to inject them into the core. That's what they call the core, is kind of the US because it's the biggest market, right? So I live in a product organization. Solaria has a large product team, like almost everybody's product. Oh, well, of course, they have software engineers. That's a sizable team too. but I feel like we are surrounded by product, and that was a very attractive proposition for me. But again, so Solaria is an organization that is encouraged to do innovation inside the larger organization, and that's a really attractive proposition for a data science team, especially because Solaria has also different products in different markets and different things that are really easy to innovate, and it's kind of playgrounds for innovation, and that has been really cool so far. I mean, I've only been there 3 months, but so far I can see the benefits to be close to something like that.
It's really interesting, Glenn. Thanks for sharing. So one thing I'm interested in is if you can speak more to any like applications that you've been able to successfully use machine learning to help within the insurance industry, either at American Family Insurance or Solaria Labs. And you've only been with Solaria for a little bit of time so far, but any differences you can speak to on like kind of areas of focus that they're trying to use machine learning for?
Yeah. So I was super pleasantly surprised. So there are some overlap stuff that I had done in American Family that, of course, Liberty is also really interested in doing, right? There is a lot in general in the industry. There is a lot of kind of exploring the use of computer vision for extracting information from images. So, and more concretely, aerial images, right? So there is a lot of potential for there is all these vendors that provide, images, and I can talk more about in American Family, right? Because now it's public. I mean, back in the day, there was a lot of exploration about how we can use these images in order to verify attributes of a property, either for underwriting or for pricing and stuff like that, right? Like things that you want to check or agents and stuff like that. For example, you for a picture you can create a model that detects if there is a pool in the property or not, right? You have a service where you can submit an address and then you get all these images, aerial images, and then you have your model trains so you can detect there is a trees around the property. You can detect if there is a tree overhanging the property. You can even have a kind of a sense of the roof condition. There are many different things like that you can assess from images right now, right? Automatically. Either to confirm some of the information that you have or to create new information to make decisions. So American Family also work on that, and they kind of create a spin-off of that is called Arturo AI. I don't know if you've seen it around, but it's based on that. It's basically using computer vision for things like that. There is also the other part of it that is no aerial imagery, right? But it's more like how you can create images to, you might think in a future, and we had this conversation many times in American Family, and I don't think that has been realized yet. And there might be some startups that are trying to do things similar. I mean, I know there is a startup that does it for specific things when you have an accident, but you might think about like you have an accident and then you take a picture of your car guided by an app, and then AI can analyze those pictures and tell you if the car is going to be a total loss, which is a really good customer service. I mean, it's bad news for you, but it's going to be, hey, we want to pay you. The car is not fixable, and in 3 days we can tell you, oh, wait, right there, very quickly, you're going to get all the money back from this car. Or, well, this kind of accident is better. These are kind of the shops where you can take this accident. I can go and schedule a shop right away, and this is going to be the deductible is going to be met or not, and stuff like that. There is a company called CCC that does a lot of that, like assessing accidents based on AI and computer vision. That's a big thing. So there are many different things like also that kind of stem from that. So one is you might know so there is Apple starting to put this new technology in the phones called lidars. And lidars is kind of a sensor that kind of sends a lot of small tiny laser beams and then come back, they are read by a sensor. So what you do with this lidar, and you have it in the phone. I mean, like I think the iPad has it right now, the new iPhone has it too. And I think, I mean, it's not crazy to think that Android phones are going to have it, Samsung and stuff are going to have it in the past. So what you can do with this is you can render 3D models of things, right? And so a project that I did with the University of Wisconsin is like assessing these new technologies and seeing how well can we, by going around your car with your phone after an accident, how well can we create a 3D mesh model of your car and then compare it to a stock 3D mesh that we had on file already, and then kind of explore the delta. and then say again, like try to assess the accident. And the hypothesis is because you have 3D information and you have this modeling information of your vehicle, you'll be able to assess much better than pictures. Even more, you can combine it with the pictures as well, and do in a hybrid approach of using computer vision plus this kind of more machine learning 3D shaping techniques, and you can have a very good assessment of how your vehicle is after an accident. And I want to stop here because I know I'm saying a lot of stuff, but
Awesome. Go ahead, Todd.
Yeah, that's great. Thanks for sharing. Is there any applications with natural language processing in the insurance industry as well, or is it mostly just computer vision type focused on images?
no, there are many in NLP. So customer interaction is very power right now. I mean, there is a lot of opportunities for computer vision. So when I was at Siemens, one project that we did, it was so in insurance there is a lot of information about products that products are complex, and I would say, when I'm working on healthcare and retail, I will say that the data and the problems coming from insurance are the more challenging ones, just because insurance changes the difficulty and the nuances of the data and the processes. They change a lot based on location, so different states have different regulations and stuff like that. So it's a very complex, like, you want to understand the products of insurance, there is a lot of things going on there. So one of the things that you can use natural language processing is to kind of understand insurance language and do not only the kind of retrieval, like modern, as you know, like, I mean, we have all Elasticsearch and kind of TF-IDF based retrieval that's been proven very efficient forever. But there is a lot of space for leveraging kind of more complex queries that take into account context. Context is very important in insurance. Like TF-IDF just count words and they don't understand context. So, for example, in insurance, you play. I done this before in demos that we had done. We kind of play the game of completion. What is it called? A mad libs. So you can say, for example, you can put a phrase and say, an umbrella is used for, and if a general kind of language trained on Wikipedia, it will say for when it's raining or something like that. But in insurance, umbrella is a very specific term. It means like, if you already have property and auto, it's kind of a more overall coverage that tries to protect the customer from going over the coverages that they already have. So that's an example where you play Mad Libs with a model trained in insurance data. We would know, and it would say, oh, umbrella is an extra coverage that you have when you already have auto and property or something like that. So that allows you to create these systems that are very good for information extraction and question answering, like these QA models that have been very recent. We kind of created one in American Family, which people can ask, what is the minimum age for a good student discount? And the thing goes and say, 25 or whatever, the maximum age, 25. So there is a lot of applications. The other one is when people call because they have an accident or they want to describe something or type what happened. So when you have an accident, there is this large tree of questions that you have to ask in order to route the claim to the right person. And right now, kind of most insurance carriers, what they have is they have this tree of questions, and if the answers is that, like a bunch of questions that you have to go through, and depending, it's very static, and depending on what is happening, ask you different questions to refine and figure it out. But we noticed that you kind of think ahead and do that, but at the end of that process, you ask the model, the person, the user, can you then say in your own words what happened, describe the accident? And they do that. Then you can kind of correlate the different answers to the questions that you need answers with the input, like the human kind of story that they're telling. And then you can train models that do the opposite. So at the beginning, you don't have to ask questions anymore. So you just tell them, hey, thank you for contacting us. Can you tell us what happened? And then the NLP model will answer most of the questions with high accuracy, and only will ask a few questions if it needs to, if there is some uncertainty in some answers. So again, there is a lot of that potential for NLP. There is a lot of classification problems in the insurance domain too. Like, you need to know exactly. There are problems that have in insurance, in underwriting. There are things that have like 1,000 classes of things, and your price and your risk depends on. So supposing you have a business, and if it's a food business, it's different if you do barbecue or if you do pizza, because the risk is different. And to classify that based on descriptions is very important. So there is a lot of interesting NLP applications as well.
Also, how available are the data sets for insurance applications? I haven't ventured into it before. So I'm just curious, like where are these resources available for someone who wanted to start getting their feet wet on these applications? And also, with regards to the computer vision one as well, are there any data sets available online that
There
people
there
use?
are a couple. There are some. For example, there are. I mean, the problem of odometer capture is another one that you take a picture of your dashboard and then we can read the mileage for all different numbers that you want to read. So there are public data sets that out there that can provide you with some of those pictures and some of the labels so you can train your own models. When we were in American Family, we ad hoc we share some data sets also. I don't know if they're still up, but we share a couple of data sets for that. Like, you can train models to extract digits.
Oh, I see.
But I know there is a couple around, so there is some of that data around. And with the text data, it's a little bit more complicated because some of this information is proprietary, especially how do you price people and what it means to be in that class and stuff like that. It's a little bit harder. But in general, yeah, I think some of the computer vision, I've seen some public available data set over there.
Oh, that's awesome. Thanks. So, also, another question I had for you. What are some of the challenges that you currently face or have faced in the past with just machine learning products and models in general?
Yeah, that's what I was telling you about product a little bit related to that. So I think there has been lately in the last, I would say, 5 years or so, kind of a renaissance of what we call insure tech. It's a lot of startups trying to, and a lot of them are driven by AI, not all of them, right? There is a lot of openness to include some of these techniques into the insurance process. As you know, like on the other hand, insurance is very traditional in a way because even when they are, it's funny because I always tell people like they are, insurance is kind of the one of the first. I mean, there are insurance companies that have been around for 100 years and 150 years and stuff like that. But they were like the original kind of data science applications. They were really, the business was really reliant on these kind of models that try to predict risk, to put people in different buckets and price it. So traditionally data, they're very data oriented in order to make the business work, but also because things have worked so well for insurance companies in that way, there is also a lot of tradition in that. So bringing new techniques, either because perception and people being used to do in a way, but also because of regulations. Like, so for pricing models, the standards is using linear models, GLMs. And
Hmm.
those have been forever like that. And there is no reason. I mean, that was something that was very surprising to me coming from insurance, like saying, well, but why don't we use like boosted gradient trees or random forests that would do much better than a linear model? But the issue is that regulators, they need to understand the models to approve it, and they need to be able to identify and make sure that you're not doing anything ethically wrong when you're pricing something. And they are really versed in linear models. And I think that's one of the reasons why a lot of kind of the very insurance, kind of hardcore insurance models for pricing and underwriting are based on more like statistical techniques, GLMs and stuff like that.
Hmm.
I think that's started to change in some states. Like regulators are getting more familiar and comfortable with new models and opening a little bit more. And so depending on regulation on different states, I think that's becoming a possibility right now. That's also an advantage about having operations in other countries. I think regulations are less strict in other countries, so you can experiment more with that kind of models in the case of liberty.
Right. Also, I was just curious, is there any interest in looking at the responsible AI side of the spectrum? As you know, in the insurance company, you deal with a diverse audience. And is there are you looking at research in such areas, responsible AI?
Very much so. It's a big topic in the insurance. And again, like, and I want to say a couple of things, but just for the record, these are like my opinions, not reflecting like Liberty opinions.
I understand. Yeah.
But you think about it, like in the insurance domain, and this is not a secret. I mean, it's open. Everybody knows this. Like an example of that is a lot of these models use very heavily credit score. I mean, there are a lot of studies that correlate credit score. And there is an argument about being biased, like towards certain kind of populations. So the credit score might be a bias estimator and a
Mhm.
bias. things. So they have been all this problem. The problem is they have been all these efforts, and everybody's aware of that. The problem is like who's going to stop using it first. So that requires a good coming together and kind of the nuclear weapons kind of treaty, right?
Yep.
We're going to use it. But I think there is a lot of willingness to do that. It's just people still figuring it out. There are alternatives. So this is very interesting. I don't think we have talked about this, but a really big differentiator on insurance right now, especially after the pandemic, has been the concept of usage-based insurance. You pay as you use your vehicle. That introduce solution for some problems, and it complicates a little bit other ones. But the concept here is that through an app, you sign into this special program and you just pay as you drive. And even through an app or to a dongle that you inject in your car, you sharing your private information, acceleration and location and all that with your provider. And you can get like bonuses if you are a safe driver, or there's some scores that you can do like that. That's an alternative to use credit score. In a world where everybody decides and the data is safe, it's private, we're not going to share it or anything like that. In a world where that happens, you might think that you don't need credit score, right? Because you're only kind of basing pricing on the way that people drive. I mean, that's a possibility, but it's not like the main driver of using usage-based insurance. It's more like providing better service customized to people's needs, like people still working from home. So you don't need to pay a whole, year of insurance. You only have to pay when you drive, and you probably only drive now. You don't go to work every day. You probably only drive when you go to buy groceries and stuff like that. So all that is very interesting because, again, might solve some of those problems, but it might create new ones now, again, because privacy and stuff like that. But yeah, it's a complicated field, but I think there's people thinking about it. So there are openness, and it's a topic like there are mandates for the big companies about being ethical and being able to, be kind of cognizant of the difficulties and how we can do things better. So these models are no bias and stuff like that. I know you heard there's a couple of stories too, and I don't want to say names, but they were about very out there insurance companies that were doing computer vision to detect fraud.
Yeah.
They ended up being in the cover of the New York Times and stuff like that. And that's the kind of stuff that you don't want to happen if you're an insurance company, right? So,
Right.
of course, there are a lot of worries and concerns about that.
So thanks, Glenn, for sharing more about responsible AI and this idea of using, an app to like pay as you drive for insurance. One thing I can gather from looking at Solaria's Labs website is they talk about future of shelter, like how people live is evolving, the future of mobility, how people are changing the way they move, and the future of commerce, how people no longer work a traditional 9 to 5. You kind of touched on some of this already, but Solaria, in my understanding, is kind of interested in evolving the insurance to meet the needs of customers in this changing environment. So anything further you want to expand on, or you kind of see your work with Solaria kind of helping in that regard?
Yeah. I mean, it's the portfolio is very wide, and then we interact with different parts of the whole insurance ecosystem, and also learning about different problems that stem from different countries where we have operations, right? Like a big question is, if we live in a world where we can facilitate the workflow and the interaction between information that we need for vehicles and insurance, not only that is technically possible, but also like how is the user experience, right? Like people were interested in that. So that's why external markets, because they are smaller, they are more nimble just because of that. And so it's very good. Solaria does a really good job of setting up really cool, kind of quick, like POCs or test and learns with this company. But yes, so there is a lot of that. Solaria also does a lot of engaging with the customer in different ways. For example, like applications where we can advise the customer about based on their properties, about what are the kind of things to look for. We noticed that you have this kind of, I don't know, like sink, and those are known to cause accidents. But if you do this maintenance or you check these things, those are very less likely to happen to you. You can also do connected home, and you can get these devices and connect it to our app where we can tell you there is something that is leaking. So stuff like that. How can insurance not only be, because nobody wants to interact with insurance that much. Like I don't. I just want it when I buy it and whatever when I have an accident, right?
Mm-hmm.
There's nobody's like super excited to interact with insurance. But what we're trying to do, I mean, I think part of that stuff that insurance is moving towards is to be a more integral part of your life and helping you in things that are day-to-day things at the same time getting information that it will be better for the customer because then you have less prone to an accident, but at the same time also helps the insurance company because it's less risky. You become a more safe customer and stuff like that.
I will say this, not to be controversial, but when people perceive the insurance companies or insurance companies in general, there's this perception that they're in for just the money, right? When I say in for the money, what I mean is that, like, as long as you get that rolling payment on a monthly basis coming in, they're good.
Yeah, exactly.
Once you get into an accident, they're gonna come for you, seriously, stuff like that. The reason why I say this is that you were talking about, and I love what you brought up here, where you said that making the insurance companies sort of more useful or more connected to the end user. Do you think that the end user might perceive that interaction as a way of exploit?
Yeah, I mean, hopefully not. That's not the kind of purpose. I think it's more a convenience and putting more services there and engaging the customer. But I see your point. I think by providing more services and use, like for example, one thing that Solaria provides, and it's just a very simple thing, but it's very powerful, is like we can give you weather alerts. Of course, you can get those from different places, but more like customized to what you have. Like, and you can also kind of provide actions into that. If we know that it's going to be a hail, although hail is pretty hard because you don't know much in advance, but if we know that your area is very risky for hails,
Yeah,
we could eventually send you, there's these really interesting things that you put on your car and you inflate them and kind of protects the car if it's outside, so you don't have to file a claim by hail after because it protects your car. So I think that's convenient for both, right?
yeah, that's good. That's
Opportunity and stuff like that. But I think that's the spirit. It's more like, well, of course we're doing something that it will be in the insurance interest, but I think the customer is first. Like, you will be, I mean, I'll be happy if I don't have to take the car to the shop and get everything.
exactly.
It's gonna get messed up anyway, right? I want my car original as it is, and I think a lot of stuff like that with the property too. What kind of things you can do to make sure that your house is good, and how we can help your maintenance. And I think that's kind of insurance is moving towards that, and again using kind of the IoT, the Internet of Things, to
Yeah.
for that and machine learning. So that's kind of a long term vision there, but I think there is a lot going on in that space.
Yeah, we had a guest speaker last couple of weeks talk about basically seismic data and just how the Earth is moving towards being able to get information, or AI or ML advancements is moving towards the ability to get information about like earthquakes and things like that. And I think that those added features, like you mentioned, sort of gives the customer some level of confidence in the insurance company, if that makes sense. So yeah,
Yeah,
thanks
makes sense.
for bringing that point up.
Yeah, so that's really interesting to hear how, the insurance company can help the customer, but also help themselves. And hopefully that will be the case and people won't feel like it's intrusive and everything like Yano mentioned earlier. So we've spent a fair amount of time talking about the insurance industry. I wanted to circle back, if it's okay with you, real quick on the healthcare space. I know you were recently a board member with X2AI,
Yeah, yeah.
and I'm just wondering if you can share more about what they were working on, and in general, if you have any ideas on how machine learning or computer vision can maybe help improve the healthcare industry.
Yeah, that was very interesting. That was, I mean, I kind of worked with them for a while, and I was on the ethical board. It was to make sure that, they were thinking about possible ethical issues that might come up. But X2AI, what they do is they provide conversational agents for psychological support and medical support in general. I think they have been expanding more. But yeah, the idea is that I don't know if it happens to you, but at least in the state of Wisconsin where I live, it's like that. Like, if you want to have access to a psychiatrist or psychologist, it takes a long time to get in, right? And for some of these cases, especially during the pandemic, people might have issues that they want to talk to somebody very quickly about, and and it's always hard to kind of filter in a way when your case is escalated enough that you really need urgent attention or not. You just do the triaging there, to the triage. Could be hard because you need resources of people to do that. So I think, so what X2AI, the idea I mean, they have been a startup for a while, but they got really good support, and I think they have been growing pretty quickly. It's about like having a conversational agent that can help you navigate about your symptoms and the mental crisis again, and then kind of either give you some help right away, like, oh, go and read this material, go and do this, go and do that, or try to connect you to a human as soon as possible. And they have a lot of stories when they show that this is, with veterans and different populations, this works. So it's a very interesting company, right? Again, it's based on they. It's very interesting because they're in the forefront of using these large language models, as you might know. Probably you are familiar, and the audience familiar with GPT-3 from OpenAI.
Yep.
Uh, they had access to the model really early on. For sure, I know that they really kind of experimented with that. And of course, the problem here is these models are so powerful, they always have a mind of their own. So you have to really kind of design guide rails around these models because they, again, with what big power, they can go either way. I mean, they are so powerful in there. But I think they have done a good job of doing that, and seems like the app have both like this very smart feeling and helpful for people to use. It's a crazy concept. I mean, if you think about it, it's a very out there concept, right? But I think they have been around only like for 5 years now, and they have been really kind of careful with this, and I think they're doing pretty well.
That's awesome.
And just you had mentioned earlier with Siemens that you worked a little bit in your second half of your time there on some personalized medicine. Could you just kind of expand on that and like how you see computer vision or machine learning kind of helping in that regard?
Yeah, I mean that has been evolving a lot in the last years. I mean, I haven't worked on that for a while, but the idea back in the day, we have all this massive kind of amount of data coming from your body in a way, right? Like at that point, there was a lot of interest on doing genetics, and I think that's more like they found a niche now, and that's an industry more about like take these assays, samples of your DNA, and then we can kind of associate that to different diseases, right? I think we're getting better and better to measure that. So I was really early in the days trying to experiment to link different, like they call it like these DNA assays to different diseases and see as a way of using feature selection to detect possible pathways related to diseases. I mean, they still do it all the time, and they're doing it for designing drugs. They're doing it for finding correlations between genes and diseases. So that discipline has gotten much more sophisticated as the years pass. But I think when I was there, it was the beginning of that, right? And then we created a few models for hypertension that I worked with a few researchers on Holland, on Netherlands. That was very interesting. Like they have a study where they took a lot of different measurements, including genetic information from a cohort of, I think it was they called the Pomerania region in Europe, in Northern Europe, and they really got a lot of data, and they were trying to correlate some of the genetics to you are predisposed to hypertension or not. So as an example of that, and I think this keeps going. I think there are places now where you can take you want to know what your predisposition for certain diseases like Alzheimer's and stuff like that. They have all that figured out now with similar techniques, right? So you can take a blood sample, send it on the mail, and then you get a report about, oh, be careful because you are at risk for X, Y, and Z, and these are the things that you can do in order to mitigate that, or changing lifestyles, stuff like that. But that was the concept originally. Just use this kind of machine learning in order to find correlations between different markers, biomarkers, and diseases, right? That was a lot of the work there that went out, the beginnings of that at that point.
I see. Okay, yeah, great. Thanks for sharing your early work in genetics and personalized medicine with biomarkers. Appreciate it. So one other thing that you mentioned earlier is some of the work that you do with the University of Wisconsin. I know you're on some boards with them for some of their
Mhm.
institutes. Can you kind of expand on some of that work and effort?
Yeah, sure. So that related to, I mean, this board more like trying to come from industry and giving advice about how the university should kind of support and approach, industry relationships. So with the engineering department, there are all these very interesting problems about, like, I feel like one thing that it always kind of is a highlight for me of these relationships, because I kind of started when I mentioned before, I kind of convinced this, working with with the leadership on American Family, and having support for the back then CFO Dan Kelly, we got this institute funded with the University of Wisconsin, where we were trying to link kind of researchers to industry. And what is interesting there, and I would say, like, there is always a difficulty about that, because I think there is a gap on language. And I think sometimes industry and academia want similar things, but they speak a totally different language. I mean, you listen sometimes a manager from insurance talking about what he wants to get done, and you hear a professor what is interesting for him to do. One is going to talk, the language. I mean, there might be a link there, or the technique plus the needs, but the professors, they don't understand insurance that much. Some of them do; they work in that actuarial kind of branch of things, but if you work in the machine learning area and you're super technical, you probably don't know some of these terms and understand the problem pretty well. And on the other side, also, like, that language of a researcher is a little bit difficult. So I think, like, trying to bridge that gap, kind of the bridge between those two, is something that I've done through the years, because I've been in both environments. That's a very interesting thing that I help some of these committees to figure out, how we can kind of connect better to businesses from the university side. The other thing too is, like, there is a lot of technologies that are coming up every day, and if you are a tech company like Apple or Google or Amazon, you probably have a better understanding of what is the landscape of the technology at any given point in time, because you have an absurd amount of data scientists and people experts on the field in your staff. Like, the number of data scientists in Amazon is absurd. I don't know how much it is, but I know it's a lot of people. And you might end up, like, acquiring that technology from the researcher, right? So you see, especially like Stanford University, the computer science department, almost every professor there has a startup. It's very normal to do that. So some of the conversations, and then that has IP implications, right? Like, so when you have some research and the industry wants to be part of it, how that IP works for them, how it works for the professor, and how it works for the universities, like a triangle. And some of the kind of trying to help, and some with my comments, is how we're going to do that in the University of Wisconsin, for example, for that board. Right now, I think traditionally has been the university has a strong tradition of being the university owns the IP, and we negotiate on the name of the professor, and then we deal with the industry and we figure it out, right? But I think also, like, in this new role on this more like modern world and kind of startup, a lot of professors want to own their ideas too. I mean, it's not pure academic. They see opportunities of starting a new company, especially they're really, there are a bunch of professors that are very entrepreneurial in nature. And so how to figure that out, I think has been one of my interesting things that I want to learn more about and try to help and be in the conversation. But again, to summarize, it's more like the connection between industry and research that I have been part of for a long time, and also now more like IP, how this works out, and that's a fairly complicated field about, how do you not only, like, for owning the ideas, but how do you make sure that you encourage professors to do research and being able to be owners of whatever startup they start, but at the same time, how the university plays out, and how a new industry that is coming and want to use that technology. All that is pretty interesting field right now.
I see. Yeah, very, very interesting. There's a whole lot to take in there we could talk about. Appreciate it. And yeah, I definitely like that you give back to your University of Wisconsin and help their students there understand the insurance industry, and also that you can learn more from them on how to apply those for your business as well, the new technologies.
Yeah, definitely.
It's awesome. Oh, Todd, you were going to go ahead. Yeah, go ahead, Todd.
Well, yeah, I just was going to say, I guess before we wrap up here, Glenn, any other real world applications that, could be anything outside of the healthcare or insurance industries or any other industries we've been talking about here that you kind of see, computer vision or natural language processing or machine learning really being helpful for, that kind of up and coming, that you think might be a interesting topic for someone to work on?
Well, I mean, this is not probably a stray application, but something that I've been super interested is about, we talk about NLP, but I've been really into kind of doing research on how these, large language models could be applied and used. So there is a technical constraint on some of these models. Like, we have this newer technique of NLP that appears almost everywhere in all the state-of-the-art applications that is called transformers, and BERT and all those models, Roberta, and all those models kind of fall into that. And what is great is like there are companies, Hugging Face, that they have been really fast kind of taking these academic algorithms that come out in NeurIPS and ICML and implement them super quick and add it to the library, doing an amazing engineering work, working with the researchers. So there is a lot that is available out there. I wanted to, bring up that everybody now can have access to using these models, and they have pre-trained models through these open source tools that are there. I mean, they commoditize the state of their things that are there. Like today, in 4 months, 6 months, they might already be in Hugging Face, which is amazing. So they kind of accelerate kind of how the community can absorb all these new technologies and new algorithms. So that's on one side. On the other side, I particularly have been very interested on how to make these models more faster, because as you know, these transformer models, they do something called self-attention. And what it means is like that way they are so powerful, right? So you have a phrase and they kind of explore the interaction between each term with each other. So they explore, you have a word like I'm the Lion King. So they check how important is I with the and with lion, and it is a lion with everybody. So they kind of go and explore all the relationships that are in between the words. But that computationally can be demanding. Either sequence of text is pretty large, so you have a whole paragraph with 1,000 tokens, 1,000 words. So you have to kind of check each word against each other, and that's kind of a bottleneck lately of these models. And I have been working doing research, with some people at the UW, a great team of grad students and professor, about figuring out ways to make that more efficient. So that's something that I've been interested too. But again, we actually got a paper last year on ICML, and it's already in Hugging Face, the implementation of that as well. But yeah, so I'm super intrigued, not only for the potential applications, but for the technology itself of these large language models. And for me, that have been in the field forever, still feel like magic.
Yeah.
It's so beautiful, it's so powerful. I mean, we train these models and what they can do. And there is something that I'm super excited about, and I try to bring it to different applications. And I'll link it to a very concrete. It's not application, but it's more like a general way to see things. So there is a lot of these models that they are trained in a very general way to do what we call few shot learning. So that means that, or zero shot learning, that they are trained in a very general task, and they can come and do prediction for something they've never seen. And one very particular way to do that is these models that they call entailment models. So it's a model that is trained with a context and a question or a statement, and then an answer, yes or no. So what it is like, does this statement entails this? So A entails B. So it's more like a logical question, and then you say yes or no. And then you train these models with large data sets of that, and they kind of learn the semantics of logic if something's related to another thing. And then if you do that, and there is a bunch of models that are trained with, they call it NLI, natural language inference. These models with NLI, they are so powerful because then you can do zero shot on anything. You can use it for classification, because in NLP, because you can have text and you can ask the question, is that related to the class automobile? And without even training a model, it does a really good job. So for me, this is very powerful and very interesting, because I see, related to business, that one of the difficulties with applying machine learning to business is to get label data. You probably, everybody feels that pain. But you can create some kind of value right away without the business labeling much data. Like, you don't have to create a super accurate model, but if you create a model that it creates some of the value, it doesn't have to be 95% accurate. But if it's 70% accurate, and you can kind of measure that, and you only use it when your prediction is very confident, and you can automate, instead of automating 100%, you only automate 70% or 60% of your flow. You convince the business to use these models and use human in the loop feedback in a way that the user doesn't know that it's giving you feedback, but only like if it's in a workflow, you can use this kind of feedback that you get. Then in a few months, and we have done that before in American Family, you can get to models that are 90% accurate, but it's kind of painless. And then you can create MVPs that can be deployed very quickly. the business can start playing with the stuff, and the models start getting better. So I think for me, that's kind of the paradigm, especially for NLP applications in the industry, because again, is you don't ask the business to label a lot of data that can be costly and time consuming, and at the same time you can provide some value, and your models will get what they need to get really quickly. So I think for me, that's kind of, if I can fit problems into that paradigm, for me is the best now, and I have a couple of successes in that area, so I'm very excited about that.
I see. Thanks for sharing that paradigm, and interesting to hear that. That's
Yeah. This was really, really great conversation, Glenn. I was going to start getting into Word to Vec, and the embeddings with you, but I thought to restrain myself since we're already, running out of time. But we're super excited that you joined us, and you shared so many important topics for our audience. We're sure our audience will love it. And we're sure to have you back on another session. Thank you so much, Glenn, for joining us. Todd, did you have any final words?
No, just thanks. Thank you so much, Glenn. Really appreciate you taking the time. And it was very interesting to hear more about these insurance applications in particular. We haven't yet heard too much about that, so it was very interesting. Thank you.
Yeah, thank you for inviting me anytime. Thank you.
This has been the AI Innovation Space, sponsored by Ellumen. Thanks so much for listening.
Be sure to connect with us through LinkedIn and the Ellumen website to learn more about how AI and emerging technology can help you. Also, be on the lookout for our next episode coming soon. Thank you so much for joining us. Have a wonderful day.